Hi, I'm Miss Sloan, and this is my wonderful AP Bio Period 3 class. Say hi.
Hi.
And we're going to review enzymes real quick. So first of all, when we look at the change in free energy, right? When we look here, we have the reactants, and then it drops down here to the products. So what happened to our delta G? It went down. It went negative. So would that be an intergonic or exergonic reaction?
Exergonic.
Good. What didn't change? What do you call this right here? The energy of?
Activation.
Energy of activation. And what will an enzyme do to the energy of activation? It will lower it. Perfect. Okay, so let's talk about some of the factors that affect enzyme activity. So if you increase the substrate, will you increase the amount of product you get? Yes. Up to a certain point, and that's because all of the, what do we call them? Active sites are full, right? Okay. And then will changing the pH alter enzyme activity? Yes, because enzymes are primarily made out of what? Proteins. And proteins have primary,
Secondary, tertiary, quaternary.
and primary structure is the sequence of?
Amino acids.
Secondary structure can either be a
Alpha helix
or a beta pleated sheet, and tertiary structure is the?
argon.
What did you say? Folding pattern on the secondary, good. Due to the, oh, I heard you now, due to the R groups. And then quaternary structure is when you have more than one chain. So if you alter the pH, you can alter that tertiary structure, yes? All right, and then temperature, will that affect it?
Yes.
Yes, good. All right, and, cofactors and coenzymes. So a cofactor is what? Inorganic, like a metal, like iron. A coenzyme is organic, good. All right, like a vitamin. Next, let's talk about phosphorylation. So this is where it needs a phosphate group attached to the enzyme to make it function. Who's going to put that phosphate on there? What do we call those? Kinase is good, and we're going to see that again and again as a pattern. And then, competitive and non-competitive inhibition. Competitive inhibition is when that inhibitor binds to the active site, and then non-competitive is when it binds to a secondary site, which we call a allosteric site, but it ends up changing the
shape.
Good, okay, of the active site, yes, okay. And then, in this case, you're trying to make more. You've got A, B, C, D, E, and you're trying to get to F, right? And so in this case, we have enzyme 1 that will catalyze the reaction from A to B, and enzyme 2 will do it from B to C, etc. And as you increase your product, F, it will go back and bind with the enzyme, right? And end up changing, usually in a secondary site, and end up changing the shape, good, of the active site of the enzyme and shuts it down. End product inhibition.